up using our identities to simplify expressions in terms of sine and cosines. Before we do that, let's recall what the Pythagorean identity is. So if we recall yesterday, the Pythagorean identity said that the sine squared of theta plus the cosine squared of theta, let's see, we gotta put an S there, there we go, is equal to 1. And let's remember that this could be written two other ways. If I divided every single term by cosine squared of theta, right, again, keeping this equation nicely balanced, I would have another way that I could write this. And the other way I could write this is that the sine squared over cosine squared is just tangent, right? So that would be the tangent squared of theta plus, these are the same, so that would be 1, is equal to, well, 1 over cosine squared of theta is just secant squared. Okay, another way that I could write this is if I divided all of these terms by sine squared theta. Again, keeping the equation nicely balanced. And if I did that, I would end up with 1 plus cosine squared of theta over sine squared of theta is cotangent squared theta. And that's equal to 1 over sine squared of theta. Well, we know that is just cosecant squared theta. Now, remember these two forms, these other forms of the Pythagorean identity, we verified that they were true yesterday. So we can see the Pythagorean identity either this way or we can see it these ways. Okay, so we want to commit those to memory. Now, what I want you to do is take a second and we're going to work with the warm-up problem. I want you to pause the video and I want you to separate this fraction and see if you can rewrite it in terms of sine and cosine. Go ahead, pause the video, recall what we did yesterday, separate that fraction, rewrite it in terms of sine and cosine. Okay, let's see if you got all the way down to my step here where I convert it in terms of sine and cosine. So what I did is I separated this whole fraction out. I pulled out the cotangent of A, and so I had 1 over cotangent of A in the denominator times the tangent of A that's in the numerator times 1 plus cotangent squared of A. My next step is I looked at 1 over cotangent of A and I just realized, hey, that's just tangent of A, right? So I rewrote this as the tangent of A. Remember, cotangent, 1 over cotangent of A is just a reciprocal. So I rewrote that as tangent of A. So then I had tangent of A times tangent of A times 1 plus cotangent squared A. Okay, so the next step, I looked at this and I said, okay, if we have two tangents being multiplied by each other, that's just tangent squared A. So I had tangent squared A times 1 plus cotangent squared A. My next step, I looked over here and noticed 1 plus cotangent squared A. Is that a part of one of our Pythagorean identities, one of our forms of the Pythagorean identity? And if you look, it is. We had 1 plus cotangent squared of theta equal to cosecant squared theta. So what I did is I substituted cosecant squared of alpha right here for 1 plus cotangent squared alpha. And look at that. I ended up with tangent squared alpha times cosecant squared alpha. Okay, now my next step is I just rewrote these in terms of sine and cosine, which is what we need to do. So I know that tangent squared of alpha is just sine squared of alpha over cosine squared of alpha. and that the cosecant squared of alpha is just 1 over sine squared of alpha. Now, guys, let's go ahead and simplify this. What can we do to simplify it? Well, if we multiply this out, we would end up with the sine squareds canceling. So we just have 1 over cosine squared of alpha. And I want you guys to know that you can write this a couple of ways, okay? So you can write 1 over cosine squared of alpha as this. You can just leave it as this. Or we could recall with the Pythagorean identity that if we were to subtract sine squared over to the other side, we would have that the cosine squared of theta is equal to 1 minus sine squared of theta. So we could rewrite this fraction as 1 over 1 minus sine squared alpha. We could do another step, guys, if we see it this way, and we could rewrite this as the factored form using difference of perfect squares. So we could say, hey, this is just equal to 1 minus sine of alpha, factoring this out, times 1 plus sine of alpha. If we're taking any test or assessment and you get down to this form, I would accept this. I would accept this as an answer. Or I would even accept this. Either one of those are okay. All right, guys, let's move on and we're going to practice how to simplify down to 1 trig ratio using our identities.